Lesson 8a, Momentum. Momentum is a vector value and is a way of measuring an object's inertia when it's moving. You can think of momentum as the unstoppability of a moving object. Now, if you recall Newton's first law, the law of inertia, it states an object at rest will stay at rest, or an object in motion will stay in motion with uniform velocity, unless there is a net force or an unbalanced force acting on it. Remember, a larger moving mass would have more inertia and therefore would require more force to change its velocity than a smaller moving mass would. Here's a video clip of Bill explaining momentum using a bowling ball.
Not enough momentum.
Oh, a scientist.
Bowling balls are about 3 kilograms. They're heavy enough, and we can get them moving fast enough so they have enough momentum to knock down all the pins at once. That is, if we can hit it just right. Well, that was pretty good. But suppose we had a heavier ball, like 4 or 5 kilograms. Then it would have enough momentum to knock down every pin every time. Now, that would be cool.
Hey, Bill.
Huh?
Catch.
Oh.
Let's consider this blue and this red ball. Which has greater momentum? Well, if the two balls are the same size and the same mass, then the ball with the greater velocity has the greater momentum. That would mean the blue ball has more momentum in this example. Let's consider this blue ball and this red ball. Which has greater momentum? Well, if size means greater mass, then the red ball has greater momentum, even though they are traveling with the same velocity. In fact, in this case where the red ball has a smaller velocity, if the mass of the red ball is great enough, then it may still have more momentum than the blue ball. In this case, the red ball is moving so slowly that it may be safe to say that the high velocity of the smaller blue ball may mean that it now has a greater momentum than the red one. As you can see, momentum is affected by two factors, mass and velocity. Momentum is a vector value denoted with the symbol p with the vector arrow above it. The formula for momentum is mass times velocity, or simply m times v. If the mass is measured in kg and velocity in meters per second, then the units for momentum is kilograms meters per second. Remember, it's a vector value, so we require direction in its measurement. Let's look at two simple momentum calculations. The first example is a 140-gram baseball thrown with a velocity of 126 kilometers per hour. Converting these measurements to the proper units makes the baseball 0.14 kilograms and the velocity of the ball at 35 meters per second. Momentum is mass times velocity. Subbing on our values, we have momentum equals 0.14 times 35. Momentum is 4.9 kilogram meters per second. Example number 2. How fast would a 7.26 kilogram bowling ball be traveling if it had the same momentum as the baseball that we just finished calculating? Well, the mass is 7.26 kilograms. Momentum was calculated as positive 4.9 kilogram meters per second. Momentum equals mass times velocity. Isolating for velocity, we have momentum divided by mass. Subbing on our values of 4.9 and 7.26, we find that the 7.26 kilogram bowling ball will have a velocity of positive 0.67 meters per second if it had the same momentum as the baseball.